Arithmetic progression. Now we can see how to find the sum of first n terms of an arithmetic progression. Suppose we have given here the sequence 1 plus 2 plus 3 plus etc. plus 99 plus 100. How we can find the sum of this 1 plus 2 plus 3 plus etc. up to 100? Now that is one simple method is one method is we add continuously, that is 1 plus 2 is 3, 3 plus 3 is 6 and 6 plus 4 is 10 and so on up to 100 we have to add in this manner, but it is a time consuming. What is the easiest method? Now we can denote the sum of all these natural numbers up to 100, that is equal to s. S denotes the sum. Now we can reverse the number, reverse this order. Then we again write s is equal to, starting from the 100 plus 99 plus 98 plus etc. plus up to 1. Now what we can do, take this as equation 1 and this as equation 2. Now add the two equations. Here s plus s is 2s, that is equal to, add the respective terms only here, that is 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101 and so on, plus last one is 100 plus 1 is 101. But the question arising here, how many times 101 is added? Here some terms are missed, therefore this 101 is the nth term, that means 101 is added n times. So or we say that here 100 it is, therefore it is how many times 101 is there, particularly 100 times are there, therefore 2s is equal to this 101 is added 100 times. So we can write here this is 100 times, which is here equal to 101 is added 100 times, times means multiplication, therefore the sum s is equal to 101 into 100 divided by 2. Now 2 ones are 2 and 2 50s are, therefore the sum of first 100 natural number is equal to 5050. So this is the method. Now how we can interpret this generally? Now we say that the sum of n terms of an arithmetic progression, the first term is a plus second term is a plus d plus third term is a plus 2d plus etc. The nth term is a plus n minus 1 into d. Now we can reverse this order. Again we can take this as Sn. We reverse the order of this, the sum of the arithmetic progression, that is here a plus n minus 1 into d. What is the next term? That is a plus n minus 2 into d. What is the third term? A plus n minus 3 into d and so on. The last term will be a, because we just reversed this order and rewritten here. Now once again we add this equation 1 and equation 2, so that we will get Sn plus Sn 2 times Sn is equal to, what is the sum? A plus n minus 1 into d, that is a plus a is 2a plus, here no nth term, only a is added to a, therefore a plus a is 2a plus remaining is n minus 1 into d. Now the second term here a plus d, here the second term is a plus n minus 2 into d, add these, therefore a plus d plus a plus n minus 2 into d, that is a plus d plus a plus nd minus 2d. Then a plus a is 2a, here plus d minus 2d and nth term, that is nd plus d minus 2d is minus d, that is equal to 2a plus d is common, n minus 1 into d. Therefore, this term is also 2a plus n minus 1 into d. So that every term here is 2a plus n minus 1 into d. The last term is also we have 2a plus n minus 1 into d. But how many times 2a plus n minus 1 into d is added? It is general. Therefore, here 2a plus n minus 1 into d added n times. So, it will be 2 times Sn is equal to 2a plus n minus 1 into d into n. So that we have Sn is equal to, I will write n at the beginning, that is n into 2a plus n minus 1 into d divided by 2. Therefore, the sum of first n terms of an arithmetic progression Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula we use to find the sum of first n terms of an arithmetic progression. Now related to this, we solve some problems. See the question here. See the problem. Find the sum of first 22 terms of the arithmetic progression 8, 3, minus 2 and so on. Here like previously we have find out the nth term, that is Tn is equal to a plus n minus 1 into d. Here also we use the same concept. First to identify the first term a and the common difference d. Here what is the first term? Now we can see the answer part. The first term is 8 here. The common difference d is equal to a term minus preceding term. That is 3 minus 8 is what? Minus 5. Minus 2 minus 3 is again minus 5. Therefore, the common difference d is minus 5. What we have to find? Here we have to find the sum of first 22 terms. That means S22. Instead of Sn it is S22 is equal to how much? This we have to calculate. So, we use the formula Sn is equal to n by 2 into 2a plus n minus 1 into d. What we have to find? We have to find sum of first 22 terms, that is S22. Therefore, n is how much here? 22. So, 22 divided by 2 into 2 into a. A is the first term, that is 8 plus n minus 1, that is 22 minus 1 into d is minus 5 here. Now, simplify this. 2 1s are 2 11s are 22 into 2 8s are 16 plus 22 minus 1 is 21 into minus 5. That is equal to 11 into 16 plus into minus here minus and 5 1s are 5, 5 2s are 10, 105. That is equal to 11 into 16 minus 105. Here we have to subtract this, that is 105 and 16. Here 15 minus 6 is equal to 9. Here 9 remaining, 9 minus 1 is 8. So answer is minus 89. Now multiply by 11. 11 9s are 99. 9 carry. 11 8s are 88. 88 plus 9 is 97, that is minus 979 is the 22nd term of the given arithmetic progression. We see the next problem here. If the sum of the first 14 terms of an AP is 1050 and its first term is 10, find the 20th term. First, we have to understand the question very clearly. What is given here? If the sum of the first 14 terms, sum, S-U-M, if you find the sum, it is Sn. So, sum of the first 14 terms, that means S14 is 1050 and its first term is always denoted by a, that is 10. What you have to find? We have to find the 20th term. It is not the sum of 20 terms, it is just to find the 20th terms, means we have to find A20 or T20. Therefore, we try to solve this problem. See here, what is given here? The sum of the first 14 terms of an AP. That means S14 is equal to 1050. And given we have the first term is equal to 10. What we have to find? We have to find here T20 or A20 also referring sometimes, but here we can take T20. 20th term is how much? Okay, given we have S14 is equal to 1050. That means Sn formula we use here. Sn is equal to n by 2 into 2a plus n minus 1 into d. We have given S14 is equal to 1050. So we use Sn formula here, that is 14 by 2 into 2 into a. A is how much? A is 10 plus n is 14 minus 1. The difference d is not given, therefore here d is unknown, that is equal to 1050. Now wherever cancellation is there, we have to cancel. Wherever simplification is there, we have to simplify. That is 2 1s are 2, 2 7s are 14. That is 7 into 2 10s are 20 plus 14 minus 1 is 13d, that is equal to 1050. So that now transpose this 7 is multiple here. When transposed to right hand side, it divides 1050. That is 20 plus 13d is equal to 1050 divided by 7. 7 1s are 7, 7 1s are 7, 3 carry 35, 7 5s are 35, so 0, 150. Now 13d is equal to 150 minus 20. Transpose this 20 to the right hand side, become minus 20. Therefore 13d is equal to 150 minus 20 is 130. Hence d is equal to 130 divided by 13. Here 13 1s are 13, 13 10s are 130. Therefore the common difference d is equal to here 10. Common difference d is 10. Now we come to the question, what we have to find? We have to find the 20th term here. So we use the formula again, T20, that is Tn is equal to a plus n minus 1 into d, that is equal to a plus 20 minus 1 into d. Substitute, first term a is given as 20 and 20 minus 1 is 19 into d value we just obtained, that is 10. So which is equal to 10 plus 19 into 10 is 190, that is equal to 10 plus 190 is 200. Therefore the 20th term of the AP is 200 here. Now we try to solve the two problems together. Find the sum of first 1000 positive integers and next find the sum of first n positive integers. Here 1000, first 1000 positive integer is a particular and find the sum of first n positive integers is a general. Now try to solve the answer for the question A. Here the given as find the sum of first 1000 positive integers, means we write here 1 starting from 1, that is 1 plus 2 plus 3 plus etc. plus up to 1000 positive. Find the sum of 1000 positive integer. This we denoted by S because we have to find the sum. Now we know that when the last term L is given, when the last term L is given, then we use the formula Sn is equal to n by 2 into a plus L, where L is the last term. Here L is the last term, that is equal to 100. A is the first term, is equal to 1. So n is what? N is here 1000, because question is find the sum of first 1000 positive integers. Therefore S1000 is equal to 1000 divided by 2 into A is first term, that is 1, L is the last term, that is 1000. Now simplify this, that is 2 ones are 2, 2 500s are 1000. Therefore 500 into 1 plus 1000 is 1001, that is equal to 500 into 1001, that is equal to 5 and 5 lakh 500. Now we find the answer to the question, find the sum of first n positive integers. Here the last term is n. Again we write here given as the sum is equal to s is equal to 1 plus 2 plus 3 plus etc. up to n positive integer. Here a is the first term, that is 1, and l is the last term is unknown, n we can take, n is given here. So again use the same formula, that is Sn is equal to n by 2 into a plus l, that is equal to n by 2 into 1 plus l is n. So we rewrite Sn is equal to n into n plus 1 divided by 2. This is the formula we use to find the sum of first n positive integers.